The video you're watching today is going to be about bathyspheric or underwater terrain maps. They're also called fishing maps, nautical navigation maps, or just nautical maps, although that doesn't cover everything. What they do is they discuss how deep waters are for navigating a vehicle, like a ship or a boat. Yes, there are vehicles. And we're looking at a reservoir. Reservoirs have extreme changes in how deep they are or where the shoreline is. So if someone says it was 57 feet away from the shoreline, you have to know what day, not just what year or month, but what day that was, and be able to get a decent picture of it. Now, while these are usually called satellite maps, this is actually an aerial map taken from a camera slung underneath an airplane. It'll have angles and distortions and stretching effects. Common disclaimer here is you have to look at multiple versions of the same image. Now, in this distance of 570 feet approximately, we get, if you look at a bathyspheric map, a 61-foot depth change. Let's say 60 feet for every 570 feet. So that would work out to, let's say, 6 feet for every 60 feet approximately. It's almost 10 to 1. So if you go out in the water for a distance of, let's say, 10 feet, it should drop a foot. Except we can see the lines aren't evenly spaced like that. From here to here, there's only a 1 foot depth change. Even though that's 24 and 23 feet, that's a pretty good distance. Here we see that there's a fairly extreme drop-off. Now this is a lump of material sticking into the reservoir, and there's a drop-off. If we look over here, we don't see it, but that's because this is a particular year, and that's the depth it's at. Also, this information may be very old. It also may be that someone from the county, for instance, came out and extended what is essentially a highway. It's literally labeled Old Highway 89 out here by making it a longer boat ramp, which is what it's referred to on many of the maps. So let's look at water depth in a slightly easier way. As you can see, this is a point-for-point match, and we see this. Now, this is a 2015 April aerial view done from a camera slung under an airplane on Google Earth. Google Earth has a time warp feature where I can go back and forth in time and see changes in area. I'm going to go back one notch and see if it even bothers rendering correctly. As you can see, there's a fairly big change in a 1 year period of time. Well, it's not really a big change, but you can see how much of a change it is. What we see is very likely that that is really a ridge, not just a nice flat area. So we'll go forward a couple of notches. 2016, we can see a very extreme change. Now I'm going to bring it to this one because it shows us the terrain map that we can get. Now remember, there are cars out here. They're going to mess up things, but a lot of the lines you're going to see when I zoom in will show the depth lines. Now right here we can see a gradient effect of fairly consistent change. This is caused by the water ebbing and flowing and lapping up against the surface. Then we get it slightly more flattened out looking here. And it kind of is. And you can see that this is a curved edge. It's more of a ridge here. Now, this is covered with roads, but you can see that this is, and this is, where apparently material has been brought out here to make sure there's a boat ramp. You can look up boat ramp or boat launch fail and see lots and lots of instances of people launching their cars and their boat. And you can also see the aftermath, and some of them towing it out of the water. Now, let's look at our depth map here. We can see that we have this implied dip here, right? Or is that a ridge? See, we don't have it in 3D relief mode. Over here we see this. That's implying that that's jutting out of there. This goes down to 60 feet after a distance of, let's say, 600 feet. And then over here, it's 100 feet deep. It's rough terrain by definition. Okay? All right. And if we look at it on Google Maps, if we hit the terrain data, which is really not all that useful, it does show, if we zoom out a little bit, it is rough terrain. Like, pretty extreme occurrences here. Okay. All right. Now let's go back to the normal layering here. Now this is an example of things. I want to point out that if there's a rim here or a ridge, and you were to drive out here, it might have been really shallow for a pretty good distance and then have a sudden drop off. This can be changed by people pouring out gravel and dirt to cause a change, to try to create a ridge. If a human being or if the city, county, or whatever put a ridge out here, trying to create a bridge like we see when we look at this, that means that they were causing this to have a fairly pronounced ridge. If you're to go off the edge of it, it'd be just like going off the edge of a road. Now, let's say you were driving, let's say 20 miles an hour, and you went into the water thinking it'd be kind of shallow and keep going for whatever reason, and then it started floating. Which part of your car would sink first? The front or the back? Right or left side? Right or left side is pretty much a toss-up from what I've been able to look up from statistics. There's only a few countries that test a car to see what it'll do. So unless you're looking at a specific car and its ability to tolerate passing the rules in Holland for being able to float if it's on a lake or a river, you're not going to have all the data. But should we presume that a vehicle would sink nose first? Should we assume that it could also be tipped over? Should we assume a vehicle that might have driven out this way could have gone slightly to the right of it and gone over and tipped over underwater when it finally sank? Could it tip over with the nose still pointing this way to the lower right of the screen and roll over on its back? Would this be a surprise to a person if they spent, I'm going to say, a long time or a career doing examination of vehicles that had gone in the water? And do they tip over on a regular basis? Is this something that happens often, or is it rare and therefore suspicious in an accident? In order to evaluate this, wouldn't you need to be a person who evaluates both ordinary accidents and crime scenes? Who would be most qualified? The FBI that was involved in investigating an incident out here? The local police? All of them at once because all of them did? Every armchair expert like me and you? Well, there was people who recovered that vehicle, and it was upside down at the time. And when you look up the video for it, it's a dramatic recreation, faking certain parts of the video very obviously because they weren't filming what they were saying to each other at the time by pointing a camera at themselves, unless maybe they were. Now, I'm going to do a real quick zoom in on one thing here, if it actually resolves. This is obviously a Google product. This is the scale here for the cars. This is an example of them. Would a boat ramp, by definition, have enough of an angle for a vehicle to go down into the water and suddenly start floating? Again, you can look up boat launch fails where people's cars do this. Would it be presumed if someone built this up to the point that in one case here, at least, we have the boat ramp being extended almost by putting out more material here, causing there to be a ridge here cutting off some of the water flow? Do we assume that when we look at this, which is the standard depth map for it, showing that there is no ridge here, should we assume that that isn't there? Should we still assume there's a depth change of like 60 feet and that a vehicle would have enough distance to go in, let's say nose first and tip over on its back, but end up pointing towards shore? Or could the ridge have tipped it over lengthwise, not lengthwise, but not end for end, but for, doing a barrel roll and ending up on its back after it sank? Next, would a car behave the opposite of what it would do on land? On land, vehicles have to go 50 to 60 miles an hour or even faster. They have to be aerodynamic. Are objects that are designed to be, low center of gravity, are they going to maintain that low center of gravity in a buoyancy situation? Is it always going to end up a certain way? Or can you look at dozens of incidents where a vehicle was found upside down, either pointing back the way it came or pointing the same direction it was moving, but flipped over on its back? Is this a set of statistics you can look up easily? The answer to that last part is it's actually pretty difficult. So I understand an ordinary person with no experience taking accident vehicles or crime scene vehicles out of the water. I would understand them not knowing that and maybe make a mistake. That it's not always one way, and that if you see something different, that makes it suspicious. I don't know, therefore, aliens is not an acceptable explanation here. Or should we assume that an entity has a lot of experience with this, and them seeing this for the first time obviously should indicate we should be suspicious of it? I will leave a link to the iBoating, quote-unquote, fishing app, GPS nautical charts. This is a nautical chart, but most importantly, it's a bathymetric chart. of this area in the link below. Also a link to this Google map here that you can mess around with. I can't leave a link to the Google Earth, but I'm going to go forward and back a little bit, if it actually renders, and show you the before and after of, in this case, about a year, almost exactly a year, of water depth change at a reservoir where it's pretty obvious they built up a ridge here. If someone drove a car out here, it might seem shallow at first, and like every other boating fail video, the vehicle might decide to become a boat for a while. And if they went off on this angle, once it sank, it would definitively hit probably a raised ridge and probably tip over like you would expect it to going off of the edge of a road while driving. This happening underwater isn't unusual. So, putting our presumptions aside, do we, quote, trust the expert that's making a somewhat outrageous claim? Or do we trust an internet nitwit like me? Or do we not trust either and go look it up from multiple sources? I think the last option is our best option. Also, again, if somebody's doing dramatic recreations and not labeling it under each and every part of the scene that's a dramatic recreation, I have my suspicions about them. Thank you for watching. Have a good day. I wish everyone luck with this. And my opinion, I'll just give it really quickly. This was an accident involving a person just simply taking the wrong turn. Every other detail is not relevant.